Okay, so we're going to leave half equations, redox and electrolysis for the moment, and then when we go back to school we'll do some experiments and remind ourselves of how that works. But for now we're going to move on to a new topic, okay, which is all to do with quantities in chemistry. So how we measure the amount of substance that we have. All right, so this is all to do with measuring amounts of substance. All right, and so before we do this, I'm going to use an analogy, and the analogy I'm going to use is eggs. So if you think about eggs, now you know that that's an egg, by the way. When we talk about eggs, we can talk about a dozen. So we can have 1 dozen eggs. And 1 dozen eggs equals 12 eggs. Okay, so that's the definition of a dozen, is 12. All right, so if I have, let's say, 10's too easy. Let's say 8 dozen eggs. All right, how many eggs do I have? Well, I know that 1 dozen is 12 eggs, so if I have 8 dozen, I have 8 times 12, and 8 times 12 is 96 eggs. All right, we can do this the other way. Let's suppose that I have 180 eggs. How many dozens would that be? Well, to go from my number of eggs to my number of dozens, I would need to divide by 12. So if I do 180 divided by 12, I get 15. So 15 dozen eggs gives me 180 eggs. All right. So let's suppose that I go shopping once a week, and we've got a nice. Let's suppose we've got a nice family of 4, and everyone in the family likes to have a fried egg sandwich for breakfast, all right? And they have a fried egg sandwich for breakfast every day. When I go shopping, how many eggs do I need to buy? Well, each person eats 1 egg a day, which is 4 eggs per day. There are 7 days in the week, so it's 4 times 7 eggs. So 4 times 7 is 28 eggs. Okay, so how many dozens would that be? Well, that would be 28 divided by 12. So I would need to buy 2 1/3 dozen eggs. All right, which is 2 1/3 dozen. Now, obviously, I don't recommend you go into your grocery shop and ask for 2 1/3 dozen eggs, but you can see the relationship between the number of eggs and the number of dozens of eggs. All right. So let's imagine I work in a restaurant now, and in my restaurant, the best-selling item on my menu is a 2-egg omelette. And we have ordered, let's say, 25 dozen eggs. How many 2-egg omelettes can I make with 25 dozen eggs? Well, 25 dozen eggs is how many eggs? I do 25 times 12, 300. Each omelette has got 2 eggs in it. Okay, so if I've got 300 eggs, that means I can make 150 omelettes. Okay. So why am I talking about eggs and omelettes? All right, no, I haven't lost my mind in the lockdown. There is a reason for this. The reason is that in chemistry, we use a similar system. All right, we have, instead of dozens and eggs, we have something called 1 mole. All right, so it's like the dozen, except that a mole isn't 12 eggs. Instead, a mole is a really, really large number of particles, and that number is 6.02 times 10 to the power of 23. All right, and 1 mole can be of anything, so we're just going to say it's 1 mole of particles. All right, now, this number here is stupidly big, okay? There's no way you can imagine how big this number is. All right, so don't worry that it's just this sort of meaningless number. You just need to know that it's a really, really large number of particles. So just like how we have a dozen eggs is 12 eggs, a mole is this number of particles, 6.02 times 10 to the 23 particles, okay? So we can treat this number the same way we treated the eggs. So let's say I have 2 moles of water molecules. All right, how many water molecules do I have? Well, I know that 1 mole has got this many water molecules, but I've got 2 moles, so it equals 2 times 6.02 times 10 to the 23 water molecules. All right, now I can work that out on my calculator like this. So I want to do 2 times, and then I've got my 6.02, and I'm going to use this button down here. You see this times 10 to the power of x, that one, and then I put in the exponent. So the exponent is 23, 23, close the brackets, and what do I get? I get 1.204 times 10 to the 24 water molecules. All right, let's suppose that I've got 0.5 moles of sodium atoms in a metal. Okay, how many sodium atoms do I have? You might want to pause it, have a go yourself. All right, so I know that in 1 mole of sodium atoms, I would have this many sodium atoms, but I've got 0.5 moles, so it's 0.5 times 6.02 times 10 to the 23 sodium atoms. So if I work that on my calculator, it's just going to be 0.5 times 6.02 times 10 to the 23, which gives me 3.01 times 10 to the 23 sodium atoms. Okay, so far, so good. This is fairly straightforward. Let's try and make it a little bit more interesting, all right? Let's say if I have 2 moles of methane, how many hydrogen atoms are there? Okay, so in 2 moles of methane, how many hydrogen atoms are there? Well, methane is CH4. Okay, CH4. This is methane here. All right, so I've got my carbon atom in the middle, and I've got 1, 2, 3, 4 hydrogen atoms. All right, methane, CH4. So let's think about this step by step, all right? If I have, let's say, one molecule of CH4, how many hydrogen atoms are there? Well, there's my molecule of methane. I've got 1, 2, 3, 4 atoms of hydrogen. Okay, so what if I've got 2 molecules? 2 molecules of methane. How many hydrogen atoms do I have now? Well, if I've got 2 molecules, I've got 1, 2, 3, 4, 5, 6, 7, 8 hydrogen atoms. Okay. And then let's suppose I have 100 molecules of CH4. How many hydrogen atoms would I have? Well, I haven't made 100 molecules of CH4, so we just have to work it out. I know that if I've got one molecule, that's 4 hydrogen atoms, so 100 molecules will be 400 hydrogen atoms. So now, the question is, what if I now go to 1 mole of CH4? How many hydrogen atoms will I have now? Well, if 1 molecule of CH4 has got 4 hydrogen atoms, 1 mole of CH4 is going to have 4 moles of hydrogen atoms. Okay, which means that if I've got 2 moles of CH4, I'm going to have 8 moles of hydrogen atoms. Okay, now remember that a mole is just a number of atoms, or a number of molecules, or a number of particles. Okay, so this 8 moles of hydrogen atoms is actually 8 times, and how many hydrogen atoms do we have in a mole? 6.02 times 10 to the 23, which gives me, if I do that, 8 times 6.02 times 10 to the 23, 4.816 times 10 to the 24. 4.816 times 10 to the 24 hydrogen atoms. Okay, now you might want to pause the video there and go back through that process so you understand the relationship between the number of molecules and the number of hydrogen atoms, and the relationship between the number of moles and the number of hydrogen atoms. Okay, so you might be thinking, why is it 6.02 times 10 to the 23? Why is it that particular number? Is that just a number picked at random? No, it's not. Okay, so there is a reason we use that particular number. And in fact, that particular number has a special name. Okay, and the name for that number is Avogadro's constant. Okay, Avogadro's constant, or Avogadro's number. Now, Avogadro was a scientist, and it's named after him. So it's 6.02 times 10 to the power of 23. All right. So why do we use this particular number? And the reason is 6.02 times 10 to the 23 is the number of carbon atoms in 12 grams of carbon. Okay? 6.02 times 10 to the 23 is the number of sodium atoms in 23 grams of sodium. 6.02 times 10 to the 23 is the number of water molecules in 18 grams of water. Okay? And you should see that there is special significance about these numbers given what it is that I'm measuring. And it's that, if you look on the periodic table, you can see that the relative atomic mass of carbon is 12. And in 12 grams of carbon, I have 1 mole of atoms. The relative atomic mass of sodium is 23. And in 23 grams of sodium, I have 1 mole of sodium atoms. And the relative formula mass of water, so H2O, well, I've got 2 hydrogens, so that's 2 times hydrogen, 1 times oxygen. Hydrogen is 1, so it's 2 times 1. Oxygen is 16, so it's 1 times 16, so I have 2, and I have 16, which adds up to 18. So the relative formula mass of water is 18, and in 18 grams of water, I have 1 mole of water molecules. So the mass of 1 mole of anything is equal to its relative atomic or relative formula mass. And that allows us to write out an equation linking all of these things. And that equation is mass equals moles times molar mass. Okay? Where the mass is measured in grams, the moles, we're just going to have that as MOL, and the molar mass is grams per mole. All right? So using the examples above, I can show you how this works. So we can see that for carbon, we know that if I have 12 grams of carbon, that's 6.02 times 10 to the 23 carbon atoms, which is 1 mole. So that's going to be 1 mole, multiplied by the molar mass. And now the molar mass is just the number that you take off the periodic table here. Okay, so it's the relative atomic mass, so 12 grams per mole. And you can see that that equation works. Okay? Okay, so the best thing for us to do at this point is to do some practice to see how we can use this equation. And then the more we use it, the more we'll understand how it works. So, I've got here 4 questions. All right, well, 3 for the moment. All right. Now, if you're feeling confident about this equation, you can pause the video now and have a go at these questions yourself. Pause it and then I'll do the answers and you can watch the answers. Otherwise, just carry on watching. So the mass of 3 moles of magnesium atoms. All right. Well, I know that mass equals moles times molar mass. So mass is what I want. The number of moles is 3 here. And the molar mass of magnesium is the number I take off the periodic table. So it's 24.3 times 24.3 will give me 3 times 24.3, 72.9 grams. Okay, so if I've got 3 moles of magnesium atoms, that will be 72.9 grams. Or if I give you a piece of magnesium which weighs 72.9 grams, you know you've got 3 moles of magnesium atoms, which is going to be 3 times this number here, magnesium atoms. All right, next. The mass of 0.25 moles of methane molecules. Well, mass is moles times molar mass. All right, the number of moles that I'm looking at is 0.25. So I've got a quarter of Avogadro's number of methane molecules. I'm going to multiply that by the molar mass. Now remember, methane is CH4. Okay, carbon is 12. That's 12. Each one of these is 1, but there's 4 of them. 4 times 1, 12 plus 4 is 16. Okay, so 0.25 times 16 is 4 grams. Okay, so if I've got 4 grams of methane gas, I know that it's got a quarter of a mole of methane molecules. Next. The number of moles of aluminium atoms in 10 grams of aluminium. All right, so now we're doing it the other way. So I'm giving you the mass and I want to work out the number of moles. Okay, so let's do mass equals moles times molar mass. Well, I know the mass is 10 and I want to know the number of moles and I need to know aluminium. Aluminium on my periodic table is here, 27. Times 27. So if I rearrange that, I'm going to divide both sides by 27, and I will get 10 divided by 27 equals my number of moles, which is 10 divided by 27, 0.37. 0.37 moles. Okay, and our last question. The number of lithium atoms in 5 grams of lithium. So we're going to do the same thing we did here. I know that my mass is 5. I want to know the number of moles. I'm going to times it by my molar mass for lithium, which is 6.9. So now I can divide both sides by 6.9, and I will get 5 divided by 6.9 equals my number of moles, which is 0.72. However, the question has asked me for the number of lithium atoms. All right, so what do I do? Well, I know that I've got 0.72 moles of lithium atoms, and in 1 mole, I would have 6.02 times 10 to the 23. So to get the number of atoms, I just multiply this by Avogadro's number. All right, it's just enough space to do that down here. So I'm going to do 0.72 times 6.02 times 10 to the 23. Will give me, right, so that's my number. I'm going to times that by 6.02 times 10 to the 23. 4.36 times 10 to the 23. Atoms. Okay. Okay, so here are some questions for you to try yourself now. So pause the video and have a go at these questions. Okay, so I'll just go through these really quickly. So the mass of 10 moles of NH3 molecules. All right, so I need to work out my mass, which equals the number of moles, 10 times the molar mass of ammonia, which is going to be 14 plus 1 plus 1 plus 1. All right, which is 17. So 17 times 10 is 170 grams. The number of moles in 7 grams of NaCl, so my mass is 7 times my number of moles times by NaCl, well, Na is 23, plus chlorine, which is 35.5. So if I divide both sides by this, I'm going to get my moles is 7 divided by 23 plus 35.5, which is 0.12. Round that up to 2 decimal places. 0.12. Oh no, sorry, not grams. Whoops. Okay, I'm working out the number of moles. Okay, so 0.12 mole. So that's the salt that's in your cupboard. So if you were to go out now and measure out 7 grams, you can work out, well, if I know that there are 7 grams of salt, you know, if I'm going to put 7 grams of salt on my chips, that's a lot of salt. Okay, don't put 7 grams of salt in your chips. But if you were, you'd have 0.12 moles, and you can use that to work out how many actual atoms there are in sodium chloride, which is something we'll do another time. All right, the number of calcium atoms in 3.5 grams of calcium. So for this one, you need to work out the number of moles first. So it's going to be 3.5 equals moles divided by calcium, which is 40 point, oh, sorry, not divide, times 40.1. Now I divide it by 40.1, divide by 40.1, divide by 40.1, and I get my moles equals 3.5 divided by 40.1 is 3.5 divided by 40.1, 0.087. Okay, that's my number of moles, but I want the number of atoms. Okay, so I do, to work out the number of atoms, I do 0.087 times 6.02 times 10 to the 23. And I get 5.25 times 10 to the 22 atoms. Okay, now last one. The mass of 5 times 10 to the 24 atoms of beryllium. Okay, now I can't work out the mass directly from this. What I need to do is, first of all, convert my number of atoms into number of moles. All right, so how many moles are there in 5 times 10 to the 24 atoms? So if I go 5 times 10 to the 24 and divide that by 6.02 times 10 to the 23, okay, if I do that, I will get, what is it, 5 times 10 to the 24 divided by 6.02 times 10 to the 23, I get 8.31. So this number of atoms is 8.31 moles, and now I can use that to work out the mass. So the mass now is 8.31 times my mass of beryllium, which is 9. So I just do that times 9, and I get 74.75 grams. Okay, so there's a lot of information in this video. Okay, I did it all in one go because it's all linked with each other. So you might want to go back and go through some of this stuff again. Pause it, make some notes, do the calculations again if you want to, and then you're going to need to answer these simple mole calculations. All right. Now, because we're doing things slightly out of order, because there are certain things we can do, certain things we can't do, certain things that it's best to just leave for a bit and then do it later. I don't want you to do question number 5. So normally we would have talked about concentration at this point. However, we haven't, and I'm going to leave concentration until we talk about acids later on. All right, so you don't need to do question 5, but you do need to do 1, 2, 3, and 4. All right, and when you're doing them, they're all fairly straightforward. The only one you need to look out for is this one here, where it's 6 kilograms of butane. All of these calculations, you'll have noticed, were done with the units in grams. So you'll need to convert that unit first. All right, enjoy.